Hi, in this video I'll go over a demo showing the capture of Bluetooth 5's new extended advertising using the new Ellisys Bluetooth Tracker. The Sniffer supports all Bluetooth 5 features including the long-range mode, which uses the new LE coded PHY, as well as the higher speed, which uses the LE 2 megabit PHY and the extended advertisement packets. The board I'm running this demo on is the Nordic nRF52840 Preview Development Kit, which supports all the new features of Bluetooth 5. Here in the code that I included in the blog post, we can see that the primary PHY is set to the 1 megabit per second PHY, and the secondary PHY is set for the 2 megabit per second PHY. This means that the extended advertisements will go over on the secondary PHY, which is in this case is the 2 megabit per second PHY. Now, just to note that the primary PHY can either be the 1 megabit per second PHY or the LE coded PHY. It cannot be configured to use the 2 megabit per second PHY. However, for the secondary, you can use either one of the three PHYs that are available. So after running this program, I'll go ahead and flash the board with this firmware. And now that it's flashed, I have a terminal here open that I can see the output. Oops. Let's configure it for the correct serial port. And now if I reset the board, I can see the messages. The board is now advertising. And now we'll go to the Ellisys Sniffer program on Windows. I'll go ahead and restart the Sniffer. And now we can see that it's capturing extended advertisements. If we look here, we'll see that there's 3 advertisement extended packets being sent. Each one is being sent over one of the primary advertisement channels. In this case, the first one is over channel 37, second one is over 38, and the third one over 39. And you'll also notice for all of these, it is using the LE 1 megabit per second PHY, which we configured in the firmware. Now the fourth packet that you'll see is after the advertisements over the primary channel, you'll see an advertisement using, which is categorized as the auxiliary advertisement packet, and that is being sent over the secondary PHY, which we configured to be the LE 2 megabit per second PHY. It is uncoded, which is the 2 megabit per second PHY, and if we scroll down, we can see the advertisement data. In this case, if we go back to the firmware, we can see that in this example, we set the advertisement packet to include the full name, which in this case is set to Nordic _ Blinky. And we also have the UUIDs for the service for the LED button service, UUID being broadcasting as well. If we go back to the Sniffer capture, we can see the service UUID is being broadcast. It's being captured here. It starts with 2 zeros, 1523, and if we go back to the LED button service, we'll see that this matches. The way that Nordic uses is you can specify UUID base, and then you customize or you have different UUIDs that replace the 3rd and 4th byte that's being sent out with the number provided here for the specific service or characteristic. There's also another thing to note is that these bytes are being organized in a reverse order when you specify them in the firmware, and that's because these bytes are being sent from the lowest byte up to the highest byte. So it is sending 23 and then D1 BC, and that's what you'll see here is that D1, so here's 23 D1 BC and so on. And then the 3rd and 4th packets or bytes are being sent as the LED button service UUID service, which is 1523, and that's what you'll see here. Now what we can do is we can configure this to use a different PHY. So for example, if we want this to use the LE coded PHY, we can do that, and we can switch this to use the 1 megabit PHY, for example. We'll save that, flash the firmware on the board, look at the terminal to see when the program starts, and now it's advertising. If we go back to the Ellisys program, we can do a restart and start capturing packets again. And if we look at the extended advertisement, you'll see that this is now these 3 packets that are being sent over the primary advertisement channel are being sent using the LE coded file, which we configured in the firmware, whereas the secondary file, which includes the extended advertisement packets, is using the LE 1 megabit, just like we configured it in the firmware as well. And the data is being shown here as well. The UUIDs are being sent, as well as the name. One thing to note here is that the Nordic nRF52840, basically the SDK and the soft device, do not currently support advertisement data larger than 31 bytes, which is the reason why this name is being cut off. Obviously in the upcoming releases that they will have available will probably support this, which can go up to a higher data size for the advertisement packets, which is really the use case that you want to use the extended advertisement for, versus using the legacy advertisement packets. Hopefully this makes sense, and if you have any comments, please submit them below. Thank you.